Today we are going to discuss on evaluation of blast furnace hearth lining based on isotherm shape. So whether you are an engineer, a student, or someone simply curious about how a blast furnace work, you are in the right place. So let us explore how temperature tells us the story of wear inside a blast furnace. So, why did we do this study? The blast furnace lining is like the protective wall of a hot oven. If it's wear out, the whole operation is at risk. We use something called an isotherm. Think of it like a thermal boundary to track how deep the heat goes into the furnace lining. Our main goal was to see how this changed over 5 years and what that tells us about the lining hearth. So, we are going to have a deep methodology. How did we do it? We place temperature sensors called thermocouple inside the furnace lining. Every day they recorded how hot it got at different depths. We focused on one key temperature, and that temperature is being earmarked, which is equivalent to 300 degrees Celsius. We looked at how deep that heat went using both real measurement and a computer model. So here we are comparing the actual reading and with the computer model. Then we compare them to see if they match or not. Now coming to our observation, which is a important one. Here we can have a observation for the 3 month. Early observation is of 3 month, and it is very interesting to see this figure. On the left side, we have a real data from the furnace. On right side, we have what the computer model predict. So, do you see this bulge at the bottom on the left side, which is an circle? That's called elephant's foot. It's not a real foot, but it looks like one. This shape tells us that the lining started to wear out early on, not because of it, but because of hot liquid metal was washing against it during tapping. The computer model didn't show this damage, which means real life data is super important. Here comes figure which where we are looking at how the same 300 line change over 5 years. Each line has is from February of a different year. What do we see? All the lines look similar. That means most of the damage happened early, and after that the furnace lining stayed stable. On the left hand side, we also see a small shift upward. That's not damage. It's because the air cooling system pulled more heat from one side. So it's just how the cooling works, not a problem. So, learning from the pattern, what did we learn? First, the biggest damage happened early when the furnace started running. This is what is our learning from figure number 2. The molten metal digs its path through the lining, but after that the flow becomes smooth and the lining wear much slower. That means we should design the furnace shape better from the beginning so the metal doesn't need to dig its own path. That would save the lining and make the furnace last longer. So let us coming to the key takeaways. So to wrap up, we can say the most wear happens in first 3 months, which is visible through figure number 2. The real data tells us more than computer models. The elephant foot is an early morning sign. If we shape the furnace better from the start, we avoid early damage. This approach keeps the furnace safe and saves money in the long run.